Alright, ladies and gentlemen, we're starting chapter 7-2 now, and we're moving on with the last 4 rules, 7 rules total, to simplify expressions with exponents, and these focus on the division properties. Okay, now, I want you to bear with me. This is a lot for you to take in, and I totally understand that. I want you to realize that I know this is a lot. We're going to spend a couple days after this just working on practicing them. I just want you to get all the rules down first. Okay, so what I want you to think about is what would happen if you did x divided by x. What would we get? Think about what happens when we do x divided by x. Okay, what is that going to give us? Well, x divided by x simply simplifies to 1. And why is that? Well, because think about if we had 3 divided by 3, that would give us 1. Each x on top cancels out an x on the bottom. So if I do x times x times x divided by x, one of these x's on both parts is going to get canceled out, and we're simply going to be left with the 2 other x's that were on the numerator. Let's look at some more examples of this. So if I have 2 to the 7th divided by 2 to the 4th, that can be rewritten as 2 times 2 times 2 times 2 times 2 times 2 times 2, which is 2 to the 7th, and 2 times 2 times 2 times 2. So what we're doing here is we're canceling out a pair from the top and the bottom. And notice what we're left with is just 3 2's. And that is equivalent to 2 to the 3rd power. Take a look at the x's. X to the 5th is the same as x times x times x times x times x, and x to the 3rd is x times x times x. Again, each pair can get canceled out as we go until we find what we're left with, which in this case is x times x, which is equivalent to x squared. So what do you think the rule is going to be here? How do I get from here to here, from here to here, without doing any of this extra work? Well, how do I get 3 from 7 and 4? How do I get 2 from 5 and 3? The rule is subtract the exponents. And now you notice that this rule is called the quotient of powers. And what does quotient mean? It means the answer to a division problem. So quotient of powers is dividing a set of exponents. Okay? So when we see that, we will subtract the exponent. So let's write that rule out in our notes. Quotient of powers, a to the m divided by a to the p. Notice they're the same base. We're going to end up subtracting our exponents. Okay, so if I have c to the 11th divided by c to the 8th, I would do 11 minus 8, which would give me c to the 3rd. If I have r to the 5th over r squared, I would subtract my exponents, 5 minus 2, which gives me r cubed. Let's give this a try in a couple harder problems. So in this first example, remember we're looking at only the things that have the like bases. So x to the 7th and x to the 6th have like bases, so I subtract their exponents. The top one minus the bottom one. I can think of that fraction bar like a giant subtraction sign. So that gives me x, because 7 minus 6 is 1, and we don't need to write the 1. And then I've got the y's. Y to the 12th divided by y to the 3rd, I'm going to do 12 minus 3. And that gives me y to the 9th. Final answer, completely simplified. Try this one. A to the 3rd divided by a, so 3 minus 1 is a squared. B to the 9th divided by b squared, 9 minus 2. B to the 7th. Simplified. Not too bad, right? Okay, let's look at another rule. This rule is called the power of a quotient. So that means we have a division problem raised to a power. So for example, I could have A divided by B in parentheses, all raised to m. And so this is another case of that fake division. That m is going to get fake division, fake distributive property. That m is going to get distributed to everything inside the parentheses. So that gets simplified to a to the mth over b to the nth. So if you take a look here at these examples, r divided by t to the 5th becomes r to the 5th over t to the 5th. This is very similar to that rule that we learned about multiplication, the power of a product. Remember, if I have a times b to the nth, it gets distributed, fake distributed. Okay, so let's try a harder problem. I'm going to erase this stuff, get it out of our way. Okay. So it says simplify 4c cubed d squared divided by 5 cubed. So that 3 needs to go with everything inside the parentheses. It's going with the 5, it's going with the 4, it's going with the 3, and it's going with the 2. So that gives me 4 cubed, c cubed cubed, that's a power to a power. So I multiply c to the 9th, d squared cubed, again multiply, 2 times 3, 6, over 5 to the 3rd. Okay, let's keep simplifying. What else can we do? Well, 4 to the 3rd is 4 times 4, which is 16, times 4, which is 64. C to the 9th, D to the 6th. And 5 cubed is 5 times 5, which is 25, times 5, which is 125. Now, we always need to check to see if we can simplify this any further. We can't do anything with this part here. But this part of the fraction, it's possible I could do something. I need to see if I can simplify that. You know how to simplify a fraction, right? If I have 10 20ths, I look for a common divisor. In this case, 5 could be a common divisor. Oops, not the biggest. A bigger one would be 10. And I would simplify that as 1/2, right? So I'm looking to see if I can simplify 64 divided by 125. Are there any common multiple factors? That ends in a 2, that ends in a 5. I can always check with my calculator, type in 64 divided by 125 and hit fraction. I'm pretty sure that's completely simplified. Let's try another one. Down here I've got 3c cubed d squared divided by 4c squared d, all raised to the 3rd power, so I'm going to distribute that 3 to everything. That's a lot of stuff there. Okay, so that gives me 3 cubed, c cubed cubed, so I'm multiplying, d squared cubed, that's d to the 6th, over 4 cubed, c2 cubed, squared cubed, that's multiplication, 6, and d cubed. Okay, lots of stuff going on here. What is 3 cubed? 3 times 3 is 9, times 3 is 27. C to the 9th, D to the 6th. 4 cubed, 4 times 4 is 16, times 4 is 64. C to the 6th, D cubed. And now you notice the other thing that we need to pay attention to is we have like bases. Remember, these are going to get subtracted then. So I've got 27 over 64 that stays as a fraction. C moves out of the fraction now. 9 minus 6 is 3. And 6 minus 3 is also 3. Okay, so 27 divided by 64 times c cubed times d cubed. That would be our answer there. All right, we got 2 more rules today, guys. Hang tough. Negative exponents. We talked about this in pre-algebra, but I'm sure some of you are going to have some trouble remembering, so I want to go over it again. So I just want to start with remembering that there is a pattern among exponents. So if I'm doing 3 to the first power, that's 3. 3 squared, that's 9. 3 to the third power, that's 27. 3 to fourth power, that's, oops, clicked on the eraser, 81. Okay, so what do you notice as we're going through and looking at these? Well, 81 to get to 27 is divided by 3. 27 to get to 9, divided by 3. 9 to get to 3, divided by 3. So 3 to the 0 power we can figure out by taking the previous answer and dividing it by 3. So 3 to the 0 power, 3 divided by 3 is 1. Okay, so anything to the 0 power equals 1. How about the negatives? Well, again, divide by 3. So I could write 1/3, 1 divided by 3. How do I figure out 3 to the negative 2 power? Well, divide by 3. So that's 1/9. Now you could do that math in your calculator, no problem. I'd like you to try to fill out the rest of this table. Click pause and fill out the rest of the table. Alright, there's your powers of 5. You'll notice that the pattern is as we go down, we're dividing by 5. You'll notice that 5 to the 0 power is also 1, just like 3 to the 0 power was 1. And then you'll notice that we're starting to see a pattern here in the negative exponents. Where has that 25 been seen before? Up at 5 squared. 5 to the negative 2 is just 1 over 25. Same thing with the 3 squared. There's that 9. 3 to the negative 2 is simply 1 over 9. So I want you to try to take a guess here. What do you think 10 to the negative 2 is going to be? It's going to be 1 over, right? Because that's what everything else has looked like. And what is 10 squared? 10 squared is 100. So it's 1 over 100. What would be 10 to the negative 1? 1 over 10, because 10 to the first power is 10. Okay, so the rule for exponents is that anytime you have a negative exponent, that negative exponent simply can be written as a fraction with a 1 in the numerator and the power in the denominator except as a positive. So that negative just simply disappears because you've moved it to the bottom of the fraction. So for example, 2 to the negative 4th becomes 1 over 2 to the 4th. And the opposite is also true. If I have 1 over j to the negative 4th, I can move it to the top of the fraction to make it positive j to the 4th. Okay, so let me show you a couple examples here. I've got x to the negative 4, y to the 9, z to the negative 6. So anything that is negative is going to move down or move up. Anything that is positive stays. So the y to the 9th is going to stay put. Anything that has a negative needs to switch to the other side of the fraction bar. So my z to the negative 6 is moving to the top. My x to the negative 4th is moving to the bottom, and all the negatives disappear when they cross that magical boundary of the fraction bar. Let's try another one. A to the negative 2, b cubed, c to the negative 5. The b cubed will stay where it is. Anything with a negative is going to switch. So the a will move to the bottom with the positive, and the c will move to the top with the positive. Let's try combining some of these skills. Okay, 75p cubed, q to the negative 5, 15p to the 5th, q to the negative 4th, r to the negative 8. All right, what can we do here? I'm going to start by looking at the normal numbers. 75 divided by 15. What does that give us? Do you know? Well, it gives us 5. So that's in my numerator now, because it's the whole part. Now, the p's, those are common bases. So remember the rule there. I'm going to do 3 minus 5. That gives me p to the negative 2. The q's I can subtract as well. I'm going to do negative 5 minus negative 4. Negative 5 minus negative 4. Keep change there a little bit. Gives me negative 1. So that's q to the negative 1. And then that r to the negative 8, remember anything negative, if we move it to the top, it becomes positive. So I can never leave my final answer with any negatives in it. That's like against the rules. Total no-no. So I need to get rid of those negatives. So that means I need to create a fraction bar and move them to the bottom. Oh, don't need to write the number 1. That's silly. And the 5 is positive, so it stays in the top. The r to the 8th is positive, it stays in the top. Okay, let's try D. 36 divided by 9. Look at those whole numbers. What is that going to give us? It's going to give us 4. Common bases here. Subtract 5 minus 4. Gives us just a plain old x. And then we got common bases again. 8 minus 2. That's y to the 6th. And z's 3 minus 6. That's negative 3. So final answer. Anything positive stays in the top. Anything negative goes to the bottom, becomes positive. And when I say anything positive stays in the top, I mean any positive exponents here. All right, last rule, and this is going to be your favorite rule. I can just tell. Okay, so we've already touched on this rule a little bit, but it's the favorite rule. Any number raised to the 0 power is equal to 0. So check this out. This whole thing here is being raised to the 0 power. So guess what? My answer is 1. Yes! Okay, let's do one that's not so simple. M to the 0 power, n to the 3rd, n to the 2nd. So that m to the 0, that's going to disappear. It is equal to 1. And then n to the 3rd, n to the 2nd, remember I'm going to subtract those exponents, and that gives me n to the 1. So that's simply my final answer of n. Okay, so here's your homework, guys. I know that took a while. I'm sorry. We're not doing any of the evens. I'm going to be nice on you. We're only doing the odd problems. Okay, good luck.